Alright, so hi guys. So I was gonna make a video, and I was gonna do, well, I did do a video, but unfortunately the video didn't record properly, so give me a second actually, guys, hold on. Okay guys, so I went ahead and just rewrote a different problem. We want to go ahead and find a polynomial function. So it says find a polynomial function f of degree 4 whose zeros are given. So the zeros are x equals 7 plus I, x equals 6, and x equals negative 6. So there's a reason why it is of degree 4. So let's first write down our zeros. So x equals 7 plus I, x equals negative 6, and x equals 6. So let's go ahead and just get the easy stuff out of the way. Number 1, if x minus a, if x equals a, so if x equals a is a polynomial, is a zero of, sorry guys, hold on, f of x, then x minus a must be a factor. Of f of x. And then number 2, if x equals negative a is a zero of f of x, then x plus a must be a factor. So you kind of do the opposite signs. Of f of x. So here, at least for these two different these two different zeros, right? We have x equals negative 6 and x equals 6. So the way we would do this is that since x equals 6 is a 0, then a linear factor of f of x must be x minus 6. Okay, so we know that that is one of the linear factors. And then similarly, if I do for x equals negative 6, so since x equals negative 6 is a 0, so since x equals negative 6 is a 0, sorry for my handwriting, hold on, then x plus 6 must be a factor. Okay, so so far the factors are x plus 6, x minus 6, and so then from this we're just going to go ahead. Now we need to find the actual factors when it comes to x equals 7 plus I. So x equals 7 plus I, this one is a little bit tricky. So if x equals a plus bi is a 0, then its complex conjugate x equals a minus bi must also be a 0. Of f of x. So specifically in this case, because x equals 7 plus I is a 0, we know that if this is a 0, then if x plus 7i is a 0, then x equals 7 minus I. Sorry guys, hold on. Must also be a 0. By complex conjugate 0 theorem. I know this is a lot of wording, guys. Basically, you just have to switch the middle sign and, you know, do the conjugate. So anytime you have an imaginary or a complex 0, then that automatically means that the other 0 is the conjugate of that. So it doesn't necessarily mean that if I have, you know, you wouldn't say, like, if I have 7 plus I, x equals 6, and x equals negative 6, that those are the zeros, right? I mean, yes, those are the zeros, but there's one more missing, and that would be the conjugate of 7 plus I. So you must include that conjugate. Otherwise, if you just include those 3 zeros, it's going to be wrong. The polynomial will be wrong, because anytime you have a complex number as a 0, then the conjugate will also be the 0. So I just want to make that very clear. So here we know that the zeros, the complex zeros actually, are x equals 7 plus I and x equals 7 minus I. Now, the way we're going to do this problem, so we're going to go ahead and for this part of the problem, right, it is tricky. So we know that if x equals a is a 0, then x minus a is a factor of f of x. Using this definition, guys, we're going to go ahead and just state, we're going to make a equal to 7 plus I first. And so what we're going to do is we're going to subtract 7 plus I. Okay, so x minus the quantity 7 plus I. So then we know that one of the factors will be x minus the quantity 7 plus I. So this is one of the complex factors. So this is one of the complex factors. Complex linear factors, right? Since we know that the other a value is 7 minus I, so if I do x equals 7 minus I, right, I'm going to say the following. X minus the quantity 7 minus I must be equal to 0. So we know this is going to be the other factor. So x minus 7 minus I will be the other linear, complex linear factor. So here, now that we understand this, we're going to go ahead and again state all our factors, right? So our factors, all in all, are x plus 6, x minus 6, and then x minus the quantity 7 plus I, and x minus the quantity 7 minus I. Okay, and so what we're going to do is we're going to state the following. So we know it's going to go the following way. The quantity x plus 6 times x minus 6 times the quantity x times, minus we're going to do minus 7 minus I, okay, for this one. And then, and then times, and then it's going to go x minus 7 plus I. So this is going to be the other one that we're going to go ahead and, we want to go ahead and distribute, right? So the main idea is we distribute the negative, okay? Now at this point, we're going to go ahead and just simplify this expression. This part is really the sum and difference pattern. Okay. If you don't remember the sum and difference pattern, it's a plus b times a minus b equals a squared minus b squared. So x plus 6 times x minus 6 is going to be x squared minus 6 squared, which is x squared minus 36. So that's one of the factors, right, of the polynomial. And so it goes the same way for the other one. This expression itself is going to be the following. So it's going to be the quantity x minus 7 quantity squared minus I squared, which is x minus 7 quantity squared minus negative 1. And then simplifying this, we know that this itself, it's just going to be, if you want to do FOIL method, you can, but I'm going to go ahead and tell you what it is. X squared minus 14x plus 49, and then plus 1. So then it'll be x squared minus 14x plus 50. Okay, so now we have our two factors, our two main factors, right? This, and this, right? So we finally say that f of x is equal to the following: x squared minus 36, oops, sorry, hold on, times the quantity x squared minus 14x plus 50. And now we're just going to do FOIL method, so simplify, multiply by FOIL method. Of course, you could go ahead and leave it this way, but if they want it in standard form, you want to go ahead and know how to do that. So let's go ahead and just finish it off. So we have x to the 4th power minus 14x cubed plus 50x squared minus 36x squared, and then I think it was plus 504x, I think. I'm sorry guys, hold on. Plus 504x, and then give me a second, and then minus, and it was 1800. Give me a second guys, hold on. Okay, so yeah, minus 1800. I wanted to make sure when I did it on the paper, I actually, it was switched around, but it's still the same thing. So we're going to finally have x to the 4th power minus 14x cubed. We want to combine our like terms. 50x squared minus 36x squared. That is going to be plus 14x squared. And then plus 504x minus 1800. So this, guys, is our final simplified answer, and this is the polynomial that we end up with given these zeros as well as complex zeros. So that is going to be it for this video, guys. If anybody has any questions whatsoever, please let me know, and thank y'all so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye guys.